Hello and welcome to another video, and in this video we're going to be looking at other operators that are important in Python. So in this video we'll be looking at three different operators. So the first one is a identity operator and a membership operator and bitwise operators, right? So to understand each specifically, let's start coding. So the first thing is identity operator, right? So identity operator is nothing but the operator is, right? So is. So this is an operator that checks whether two variables are have the same value or not. It is very similar to what we use as double equals to. Okay, so for example, we'll test this out. X is equal to 100 and y is equal to 100 as well, and z is equal to 150, right? So we have three different variables with three different values. Now what I'm going to do is I'm going to print the value of x is y, right? So if x is actually returns as a boolean variable, that is the answer for this particular expression, right? So x and y have the same value, so let's see what the output is. So the answer is true, right? So x and y are the same value, so we're having it as true. Now what will happen if I give x is z? So obviously x and z are not equal, so what should I get? I should get a false, and yes, I am getting a false, right? So this is called the identity operator. So the next thing we'll be doing is a membership operator. So membership operator is nothing but if we have, let's say, a list, right? So have a list named L and I have certain numbers there. So I have 1 2 3 4 and 5, right? So our membership operator is in, right? So the keyword is in, so I'll mention that here. So the keyword for this is and the keyword for membership is in, right? Okay, so what we're doing right here is we need to find if the value of a variable is there inside this list. So that is where we use n. Does this number belong to the list, or is this is this number a member of this particular list, right? So I have x, let's say not x, let's take a different variable. Let's take a is equal to 3. Now we know by seeing the list that a is there in 3, right? So we'll check that. Print a in L, right? So if a is in L, the answer should be true. Now I will comment these two out so that it doesn't confuse us, and I'll clear the output and I'll run this. My answer is true, which means a is present in L. Now I'll change the value of a to, let's say, 7, right? And now if I run, I should be getting a false value, which means a is not there in L. So which means a is not a member of L. So that is why this is called a membership operator, right? So the next thing we'll be looking at is a bitwise operator. Bitwise operators, right? So bitwise operators are nothing but operations that are done on the bit level. For example, if I let's first see a one bitwise operator, that is AND, right? So the different types of bitwise operators are AND, or and not and XOR. So XOR is basically the symbol that you find above the number 6, right? So this is the XOR. So these are the types of bitwise operators that are there. So let's say I have two values, say a is equal to 10 and I have b is equal to, let's say, 4, right? So you might have been familiar with the binary notation that so we have the binary notation of 10 as, let's say, 10. So we have it as 1 0 1 0, right? So it is 1 1 0 1 0. This is 10. So 8 plus 2 is 10. And yeah, for 4 we have the 0 4, right? So 0 4 we have the value as, let's say, 0 1 0 0. So this is 4, right? So what basically AND does is if I'm going to give 10 and 4, right? So the answer should be each and every bit should be done an AND operation within themselves, right? So 0 and 0 will be performing an AND operation, and the answer will be I'll start from here, will be 0, right? So 1 and 0 will be 0 as well, and 0 and 1 will be 0, and 1 and 0 will be 0. So the answer for this and between 10 and 4 should be 0, right? Can we check that? So A, print A and B. So now here it's a bitwise operation, right? So I will comment this out, click here, comment this out, save this, clear the output, and I'll run this, and I'm getting the answer as 0, right? So this is how bitwise operators work. So you can have the same thing as OR, right? So OR would be a different value. We'll see what value is that, and we'll try to derive the answer, right? So the answer is 14, right? So what do we have here? We have 1010, and we have 0100, right? So 0 and 0 are 0, and here it is 1, right? So will come from the left. So 1 1 1 and 0. So 1 1 1 0 would be this is 0, and this is 1, and this is 2 power 0, 2 power 1, that is 2, and this is 2 power 2, this is 4, and this is 2 power 3, which is 8. So it is 8 plus 4 plus 2. So 8, say 8 plus 4 plus 2. So that will be equal to 8 plus 4, 12, 12 plus 2 is equal to 14. Yeah, we have the right answer, right? So now you've understood what are the bitwise operations of AND and OR. So the next thing would be NOT, right? So NOT is basically just reversing all the zeros to 1 and ones to 0. So NOT of A, right? So let's see what NOT of A should be. So that is 1010 1010. If it is reversed, it will be 0101. 0101 is again 1 plus 4, right? So I think the answer should be 5, right? So that's the logical conclusion. So we'll close this and we'll write. Okay, so this is taking the MSD into consideration, so we do not need negative numbers right now. We'll have a simpler example. Let's say NOT of 0, right? So what? So the answer we'll be expecting is -1, because -1 is the MSD. So if MSD is 1, which means it's negative, and we have the answer is -1, right? Right, so we'll go into the next operation, that is the XOR operation. So XOR is something that that gives a true value only when both the values are true, right? So if I give true XOR true, right, so we'll see what the answer is. So I'll get a if both the values are true, the answer would be a false, and if either one of them is false or true, which is basically the same thing, false, right? So this would be our true, right? So true and true is the only thing that'll give me false, and everything else will give me true, right? So I will check for this also as well. So we have covered all the possible iterations or permutations of this value, right? So false and false. Okay, so it's false, true, and false. So XOR will be true only when either one of them is false, and if both are true or both are false, we get the answer as false. So this is the truth table for XOR. So these are some bitwise operations that you can explore in your logical expressions and your mathematical equations. So hope you understood, and see you in the next video. Thank you for watching.